There you go. All right, welcome to day 8 of Quick Pass. We have today and tomorrow. Tomorrow is our final day. And today and tomorrow, we are really just going to work on the mini projects. So the lottery generator we started working on last time, we're going to keep going with that. And so we had already made some pretty good progress with some of the libraries, and then making sure we had the right data types. But I'm recording this. I'll be putting this up on YouTube, so you can reference it if you're really excited about this project and you want to try and even improve it, or you don't remember how I did something. We'll have it there, and I'm going to share the code as well, so we'll have that. But before we get going though, does anybody have any questions on the material? Maybe a data type question, data collection, any methods that we needed to use, that we learned. I'm all ears for that, and I'll be happy to go over those concepts before we dive right into the project again. And if we don't have any questions on the material, do we have any more questions on the admissions process, the application? Has anybody finished their part 2 and has scheduled or even completed their assessment?
I haven't completed any of the code challenge stuff yet.
Okay, yeah, I advise you to get going on those. At least try and finish, a couple today if you can, and get, make as much progress as you can. But those, the part 2 is required before you even move to the assessment. And that, the 3rd is the last day to turn in part 2, so it's 2 days. So
If I may, since we last spoke about the assessment, I've been working on the coding challenges basically outside any of my free time. And I've been getting like 2 done a day. And that's like my top. So it's pretty tough. So I want to
yeah.
to it.
Yeah.
At least for me.
Yeah, they are tough. And but this is this is a great way. If you finish this now, and even if it's super hard, you get it finished and get through the assessment, then that gives you freedom to choose the cohort without having to go through the application process again too. So but even if you don't make it, you can always try again. You can always go through the application process again. And sometimes it just takes a little extra work, but I'm going to try and get you to the finish line, expose you as much as I can to these basic 4 methods. We have them written down. There's variable assignment, reassignment, loops, dictionaries, keys and values, and functions. So those 4 things, those are key. If you can break down Python, you can break any problem into those basic data collections, data types, and then make a bunch of Boolean statements to build logic flow. If you can do that, you can get through any coding challenge really using just those 4 methods. But there's a lot more included Python that will help you.
I don't know if I signed up for this prematurely, but I'm actually trying to get into the DevOps cohort in November, the weekend and evening. So I guess there is not a lot of rush on the assessment there.
Yeah, it's still, once you get through though, the application process is the same for either one. Once you get through it, you're in, right? So yeah, it's still important to learn this stuff so you can get through the assessment, even if you're going to go to the DevOps versus the full stack. Murad says, I have a problem with how to initialize a Boolean variable before the loop. Let me open up a new Jupyter notebook here, and I'll see what we're talking about. So let me add one here. I'll just say share my screen here in a second. Okay. Share screen. All right, can everybody see my screen? Okay. Let me open up a chat window again. It goes away whenever I do that. All right. Okay, so let's see if I can understand the problem you're having. So you're saying you have a problem with how to initialize a Boolean variable before the loop.
Yeah, because sometimes we initialize the Boolean variable. Okay, I can't understand how it confusing me that the Boolean flag pattern, when you start with in the beginning with true, okay, sometimes, and you flag with false, and sometimes you start with false and flag with true. Okay, that's really confusing me when I solve the problem. Most of the time I have to change it many times because I have like no, or there is nothing, like, I don't know how to say it, but there's no standards. When should I use true, okay, and flag was false, and when should I use false and flag was true? This one thing. And the other thing, when I use the storage variable before the for loop, it's also confusing me sometimes, because all the problems depend on the iteration and the loop. Okay, so if there is any way or any standard, or like if you can tell me, oh, you use this when the problem need, for example, to find, like the example that you give it to us about the name list. Okay, we were looking for name inside the list, so we called and we said, okay, we're gonna start iterate over the elements in the list until it find it. If it find it, it will say, it will turn, give flag and turn this variable to true, right? This was a good example, but sometimes is not clear for all the problems. So is there any strategy for using the Boolean pattern, or we just take it like by sense?
Okay, so let's think of a I mean, we can go back to, let me see here. So we can maybe take a look at this and kind of see, how we can kind of show you, like in this example here, I have like, let me see if I'm doing that here. Okay, so I was we had this code at the end of the day on Monday, and I think here, like, I'm establishing like a variable before a loop, and then I wanted to like append it, but it looks like I commented it out. But I could also just make a quick loop to kind of show you, like, okay, what's a good example of like using like a Boolean, are you talking about like for like a while loop or something like that? Or for anything really?
No, I'm asking for loop, the for loop.
Okay. Because I mean, really, it doesn't matter what loop you have. You still need to kind of develop those Boolean statements based on the situation you're in. It's really not, there's really no standard. You just want to make sure you break the problem down all the way. So let's yeah, we'll be getting just like build a quick number guessing game, because it won't take very long to build this. Okay. And we can use the input method to actually get user input. And so let me just go ahead and build up a quick, like, a bit of code just to kind of get started. So I can say target target number equals, and I'll just do a random one. So I need to import random. So I do. And then target num is going to be random.rand int, and I'll do from 1 to 500.
Mhm.
And then I can say, let's say we want to basically allow the user to guess until they get it right. And so we don't know how many times that we want to basically prompt the user for a number, then check that number against our target number. And if it doesn't match it, then we want to return a statement saying, hey, your number's too low, or your number's too high, or you got the number just right. And so, but we don't know how many times they may get it right away, and we want to end the loop once they get it. Or if they're too low, then they can put another guess in, and once they get it, it stops the loop. So we don't know how many times this loop is going to run. So what kind of loop would be best for this kind of problem?
What
While
kind of
What's that?
A while loop?
Yeah, a while loop. A while loop is probably the best because it runs until you meet a certain condition. And so so what we can say is while and we can make a Boolean here, say match equals false. Okay, and so while not match. Okay, so now I'm saying while match is not whatever value it is. So while not false is true. So while true, which is how a while loop will run as long as these evaluates are true. Okay, or we can also say while match does not equal false. You can also do it that way if that's more clear to you. This is the same exact thing. Okay, so while match does not equal or no, while match equals false. So while match equals false, run whatever's under here, and then I can say guess equals input, and then enter your number here, and then I can then start doing my comparison. So once the user, what's going to happen is it's going to go into this loop and it's going to go right to the input, and it's going to assign whatever the user enters as input as the guess. And then I want to do some comparison at that point, because now I have a target number and I have a guess. And so I have two numbers and I can run a comparison against. And I can start driving some if statements and start making those Boolean statements. So I can say if guess, I guess the most restrictive case right now is if they actually get it right.
Hey, Aaron, question.
Yeah.
When we use input, do we get a string back or will we get a number back?
That's a good question. It will be a string, but right now we're gonna build it out and just kind of, we're gonna build it and look at the errors that come in. But yes, it's a string that comes back.
Okay.
But we can make it integer, right? We can wrap it with, right?
Yeah, we can just say int.
Yeah, and wrap it.
That's it. Now it's going to be integer every time.
Exactly, yeah.
So hold on, I gotta turn on.
I also had a question for why we put match equals false on line 4, or why that is.
I mean, it doesn't really matter, but it's the way it reads, right? So I want to trigger this and turn to true whenever we get a match, so we'll stop the while loop. And so right now we don't have a match, right? And so that's why I wanted to say, wow, match equals false, keep running this loop, and then when it's true, the loop will stop and we'll get to the end result.
Interesting. Thank you.
Yeah. And so if the guess is equal to target num, then I can go ahead and print congratulations message. Congratulations. You got the number. And I can even, I mean, I can put that number in there. I can make an F string put in there, but you just guessed it, so you should remember the number. Okay. So there's one if statement, right? Saying if guess equals the target num, then you're gonna get that. But most of the time, if you're presented with a guess number between 1 and 500, you probably aren't going to guess it the first time. So you're going to end up with these other cases, right? So what are the two other cases we have?
LF.
LF, yeah.
LF, and then we can either be higher or lower, right?
Yeah.
So LF guess is, let's say, greater than target num. Then I can say print. I said greater than. I hate those little windows. Yeah, so your guess was too high. Try again. And then I can say else print your guess was too low. Make sure I can spell. And then try again.
So Aaron, would we, as part of the if block, would we change match to true after the current line 8?
Yeah, so here you say match equals true. And then what would happen is once you set match to true, it would go back up and go back to line 5, look at it, and it'll say, well, match does not equal false anymore, and it will end.
Okay, what if we delete line number 4? What will happen?
What?
Because we already have condition and number in line 5, right?
No, so remember, this is not the same thing as that, right? What is this?
I know that's a sign and that's equal. Yeah, I know.
And this makes a Boolean statement right there. That is a conditional statement, and it's a comparison, really. It's a comparison operator. So it's saying, hey, what does match equal? What, and then what does this equal? Are they the same? And I'm stating in this statement, I'm saying.
So okay, I got it now. Okay, that's what was yeah. Okay.
Yeah, so I'm saying whatever this evaluates true, either true or false, I'm going to do something, right? So if this is true, if match does equal false, I'm going into the loop over and over and over again.
Okay.
Aaron, here's something I'm wondering as far as what's being asked about the line 4. If you did do that, if you commented out line 4 and there is no match, right? And so would it be undefined? And then it says, well, undefined is equal to false, is, because the whole truthy falsy thing, or is it just an error?
Well, right now it would be an error because you're referencing something that hasn't been assigned yet.
Yeah. And so would it be undefined, or would it be just, does match equal, since it's not been assigned,
right?
Does it go undefined?
Well, yeah, so it's doesn't exist. Like it's not even done.
Declared. It's not declared anywhere.
Yeah, it's an error because it hasn't been defined yet.
Okay.
Yeah. And so you don't have to set it to false. I think you can set it to like none if you wanted to. So I could say, actually, I don't know if that's the case, but let me see. So if I run that, let's see what happens. Yeah, it doesn't even, it just ends, right?
Who feels lucky?
Yeah, so there's our, let's see if we can do 250. That's probably the best guess, right? Okay.
I tried this with my class one day, and I did 1 to 100, and I picked some student, and the student said 77, and bam, it was 77.
And so there we go. See, it's still it's so I tried 375. So let's try let's do 280. Or no, let's do 310. Too low. So 345 to 330. 335. 340. 336. 338. 339. There we go. 339. And so here, if you look, like this is actually pretty awful because like what if you don't remember what you guessed back here? You guess those again. So you may want to have like your guess was your guess of, and then you can put in, you know, guess like that, and then put an F here. There we go. So yeah, that's the Boolean statement that you want to try and make. You want to turn something into a Boolean statement to then have it do some logic. And then these are also Boolean statements, right? So if guess equals target well, if it does, then you're good. It equals it. You know, if it's greater than, if that evaluates to true, then this line will run. If that evaluates to false, it won't run. I'm going on to the next one. So.
Okay, sometimes the Boolean statement is not mandatory to be false or true. Sometimes it could be conditioned, right?
Well, yeah, it won't be strictly, but the condition itself will evaluate to true or false.
Okay.
So you always want to make a statement that evaluates to true or false, so then it makes decisions. So it will go down a certain path that you want it to. Every single one of these statements are this one here, this one here. Those are Boolean statements. They result in something, a true or false. Same with this one.
And for that matter, Aaron, you could change all the falses to 0 and set the true to 1, and that would still work, right? It doesn't have to be a Boolean.
It doesn't, but typical syntax, you know, standard coding practices, you want to use true or false where you can. Of course, you don't want to use 0 or 1, because it just gets, you know, when you don't have standards like that, you know, you end up, you know, sometimes people have to guess, like, what does this person do? Like, what does this code mean to me as another developer working on this? And then they'll get it eventually. They're like, oh, they're just using zeros and ones versus trues and falses, but why? And so, yeah.
Okay,
Should we leave notes on the side for like if someone's looking at this project or this Boolean statement command?
Yeah, I mean, you could put like comments in code. That's actually really good coding practice to do that, and for yourself especially in the beginnings. In fact, I challenge you to do that when you're writing code and, you know, doing these challenges. Write comments in your code, and then like when you go back to it a year or two later, you can be like, that's what I was thinking. And so you'll see how much you've developed with time. And, you know, I see some of my old code, I'm like, oof, that's bad. But I was learning, and so I still write bad code, I'm sure. But yeah, leaving comments for yourself is good. Typically stuff like this you wouldn't have comments on when you're like in a, you know, if this was like a part of a function, like you would have a doc string in the front of the function talking about what the parameters are and the results and everything like that. And you may have comments over something that could be confusing, but I mean, most time when someone reads code like this, they should be able to get what's going on, especially by looking at the results of the result statements. They can kind of, you know, ascertain what's going on.
Okay, I have one more question.
Okay.
You know, we have 4 kinds of for forms of for loop. The most common form, for the direct one.
So for item in collection,
and for element in or whatever in range for I in range, and we have the four index element in numeric, yeah.
Mm-hmm.
Have the last one, the one of the key value in dictionary items, right?
Uh-huh.
Okay. Most of the time, my question is first, is there any strategy to decide which form can we use to solve the problem, okay, or to write the code based on the input? Like, I know that if we have key value, we have dictionary, yeah, we will use this one. If we have something we need to manipulate with the item and its index, okay, we will use the for index item. But for the I in range and the item in collection is very easy, but index in range and index item in enumerate, is there any strategy to decide which one shall I use? Like, I face problem, okay, I spent like 6 hours to solve it. It was asking about how to, it's about list has the input, asking you, okay, if the list has the pattern, okay, in like ascending, give this output. If it is descending, give this output. If it is less than this number of elements, put this output, okay? If it has peak or it has trough, okay, give me this, give me the index of the peak. Or
Where's this challenge at?
That is the code challenge.
Which one?
Number 3.
So this is in the actual like part 2.
Yes, part 2.
Okay.
I already solved it. I got that. I did it. Okay.
Well, other people may not have, so I can't talk about it.
No. I don't want the answer. My question is how to, or what the strategy to, is there direct, clear strategy to decide which for loop form can we use for solving any problem? You know what I mean? I already solved the problem. I did it. Okay, but it took long time because I was very confused, and I tried between the index item, between the index and index in range, and decide if shall I use the Boolean flag pattern or shall I, you know what I mean? But that's why I'm asking, is there clear strategy to decide which one instead of just trying and making the trial error technique?
Well, I mean, if you need the index for anything, so like, for example, if you are looping through something and you need to like compare something to another item in the loop, then you can use like a bit of math
What do you mean compare something where?
So like, let's say you have a loop of numbers, right? So let me comment all these out. Comment these out, and let's just make a list of numbers real quick. So my list equals, and then we'll do, okay, that should be good. Okay, and you want to know if the next number is higher than your current number.
The next number what?
Let's say I want to know, like in this loop, if the next number is higher or lower than my current number of the loop.
That would be 4 in range. I think.
Yeah, sure, if you want. So 4 I in range, and then I would do len.
Okay.
My list. Right. Okay, I have that, and I'm like, what's equal?
-1.
Yes, you want to do -1, but I'll get there because you don't want to, when you're doing comparisons, you want to make sure if you're going to be going ahead, you want to go off the bounds, you want to go over the bounds of the list, right? So I can say, okay, well,
So it will not be for I in range length, my list -1.
right, yeah, you'll do -1 right here. So you go -1.
Inside the list, and it will be we gotta start from the first item, from the first index, or from the second index, so we can compare the one with the one ahead.
Well, we just go like this. So we can say if
one plus length,
if my list I is less than my list
I plus 1
plus 1, then we can say my, or let's just say print current index is lower than next number. Okay, and then I say else, because I don't care if it's equal to or higher, I'll just say print the next number is not higher than the current index or number, whatever. Like, so the current number is lower than the next number is not higher than the current number. So you could do something like that if you wanted to.
Okay, wait if I index, what if the index is 0?
What's that?
Sorry, what the index? Yeah, that's true. Okay, I forget it. Yeah, okay.
Yeah, this will work because I'm just referencing indexes and taking a look at, you know, each one, right? But like, what if I want, so if I want to then like maybe print out the current number, I could use this indexing the same way, or I could use enumerate and then keep track of both the item and the index at the same time. So, I mean, it all depends on what you're wanting to do with the loop. And, you know, do you need to keep track of the item and the index? Then probably enumerate's the best thing for you. If you want to just keep track of the index, if you need to just loop over a certain amount of times that you define, you know, with an interval, you can do that. If you need to just see the items in the normal for loop, it all depends on the situation. Yeah, and so this one, I mean, you can make them all work.
But there's no clear strategy for that. I mean, like, if this, use this, if that, use that. You know what I mean? No?
I mean, no, that's what it is. Like, if you need to keep track of indexes, probably use range or enumerate. If you don't need to, then probably use the for loop. It all depends on what you're doing. I typically will always default to enumerate just in case, especially if it's a bigger problem I don't know yet. Like, I looked at it, I'm like, you know what, I'm just going to start taking a stab at it and see where I get. Like, I will most likely use enumerate because I don't see the harm in keeping track of an index. If I find I don't need it, then I'll remove it and I'll just go back to the traditional for loop. It all depends. I can always just change my code. So
when you say keep track of the index, so when you do enumerate, it notes like, hey, this is index 1, this is index 2, like as you're going through. Like is that the main difference between enumerate and range? Like
yeah, so I item and enumerate my list, so I don't have to use range length. So let's try and spell quickly. There we go. Enumerate my list. In this case, I would need to put some sort of break statement once, like, if I say if I is equal to the length of the list -1 or something like that, I can break the loop because I can't just designate a stop because it's just going to go to the end of the iterable. But I can use a statement to stop it using my index. So here, now when this enumerates, when this loops over it, every time it iterates, it'll assign the index and the item. So it'll say index 0 and item 1. index 1, item 2, index 2, item 3. You know, using ascending numbers is terrible. So let's say this is 45, right? So index 2 is item 45. So I and item are assigned actual values with enumerate as it loops. Every time it iterates, it'll change I and item to the
It will
next
change.
on the list.
Aaron, can you comment out lines 27 to 30 and then just print I and item so we can see?
Yeah. This is the index. I make an F string. This is the item. Let me just go ahead and move this to a new cell. There we go.
If I may, it might also help people if you printed like the tuples themselves so they can see like the visual representation of like the index is descending and then the values.
So yeah, that's what enumerate is doing. It just grabs these two items and it assigns them depending whatever the position in the list it's at. So you can see the 45 in the index or index 2, item 45.
Okay, I have a question, please.
Yep.
When shall I need the index and the item at the same time, as long as I have, if I have the item, I have the end, when shall I need it together, both item and index?
I mean, in this case, you need it both right here. I mean, like, well, I mean, if you want to print it out, like,
Yeah, because I
item
can print out the element, okay, or by element or by item, you know. I mean, why shall I need both together in the same time?
I mean, it all depends. I mean, there's other loops that are like more complex. Like, let's say you have a list of 1,000,000 items, and they all have a list of URLs that you're trying to parse through or something, and you need to keep track of, you know, like where in the data stream it is located. You may need the index and the actual item itself. You know, it all depends on what situation you're really in. I mean, there's all sorts of uses for these loops. Loops are a key component of any Python programming. I mean, how many loops did we do in the lottery project so far? So we've done 2. No, yeah, 2. 1 there. And then we have to, you know, go through how many drawings we're going to go. Oh, in this we do 3 loops. So we're going to be looping a lot. And it all depends on what we're doing here. You know, this one's just a normal for loop because I really don't want to keep an index of anything. I just need to know the drawing of, you know, for each drawing in my drawings. You know, I just want to know what the drawing is. I want to compare it. So I want to take that drawing and put it as a parameter into my compare function. And then, you know, here I want to use the range of length my ticket -1. So here I want to use the range ticket or the range method to run through this loop because I want to keep track of the index. I could also use enumerate here if I wanted to. I don't have to use for I and range. So it really all depends on the situation you're in, but sometimes you will need to keep track of the item. And you can just use index with range, but the range isn't always for looping over collection. A range just creates an iterable that you're going to iterate over. So that's another thing. Whenever you're making the range, this range loop right here, this one that uses range method, I'm not looping over my ticket. Or I'm not looping, I'm not looping over the ticket itself and the numbers of the ticket. Python is making an iterable, and this is the stop. So this is how many items are in the iterable that it's going to start going over one by one. So if I were to say for I in range 1000, right? Print I plus 1. And I run that, it's going to print the numbers 1 through 1000. It makes an iterable and then just iterates over it behind the scenes. There's no collection at all that I made. It creates the iterable right here. So the range, when you use it with a list, you're really you're getting the length of the list and then looping over that range and then just using the index to reference items in that list. You could get both the index and the item by using range. It's just a little bit more clunky. Enumerate allows you to just get the item and the index in one go. So does that help explain things a bit?
Yeah.
Okay.
And the -1 is just giving it like a different starting point.
The -1 up here.
Subtract 1.
No,
Yeah,
so what this is doing is making the range stop like one short of the end of whatever it is, only because you don't want to go all, because remember the stop of range is up to but not including. So if I just kept range length my ticket, well, in this case, I want to stop one short because I don't want to evaluate the Powerball, because the Powerball was always the last index. So I wanted to go up to but not including the last index. That's why.
We don't want to go outside the list or the collection.
Well, in this case, we won't go outside the collection. I'm not like looking at an index ahead, but remember, we don't want to evaluate because the last item in our ticket is the Powerball, and that's a different comparison. Remember, that's what this comparison is for, that only the Powerball. So that's a good segue right into our challenge, right? Our problem. We have our lottery. Yeah, that's great. Michael, yeah, when we get there to like doing prizes and stuff, because you probably went and looked at the Powerball site and found the prizes, we're gonna build that. But yeah, if you want to, share your solution, when we get there, that'd be great.
Yeah, I was thinking that when I saw that chart you shared with us about, if you have like 3 numbers in the Powerball for it. So I thought, oh, maybe we could use a switch statement. But then I realized Python doesn't have a switch statement.
Python does have switch statements.
Oh, it does.
Now,
Okay.
yeah, it's a recent development. I mean, they're just fancy if and else ifs, so I just don't even use them.
So I ended up doing it a slightly different way, not using a switch statement. But when you're ready, I'll share it with you, and then maybe you'll convert it to a switch statement.
Yeah, I mean, I've never really actually even written a switch statement in Python because I've always used if and else if. I mean, let me actually pull up documentation on that. I don't want to go into too many segues because I want to get into this challenge, but Python switch statement. Yeah, it was just released with like, I think 3.10. And we're in 3.12 now, so switch case, yeah.
That's the old style, huh?
Yeah, well, that's still the current style, to be honest. Yeah, match case. So it's called match case, I believe.
Okay.
Yeah. The same, it's just it's really the same thing.
Mhm.
So yeah. It doesn't stop you from doing all sorts of comparisons, just chaining your if and else if, but yeah. And so, did anybody else work on anything with this? You may not have had the code. Did you like copy some code down and try some stuff, or?
I tried, I got a bunch of errors. I did have a question in regards to iterate over a string and iterating over a list.
Okay.
How would that apply to this example of like picking a random number? Or would it apply?
Iterating over, what do you mean picking a random number when you're iterating over a string or a list?
Yeah, string, I guess,
Well, I mean,
or loops, or for the just trying to more clarification on the first few lines that we were working on.
oh, it's like right here on line 3 on, like creating
Yeah.
our numbers. Oh, okay.
Yes.
Yeah, sure. I'll go over this with you. So in this function, we're going to define some things, right? So really, we're using the random module, which is it's a way to create pseudo-random numbers from the bounds we select. In this case, I'm using the rand int to get 1 through 26, because the Powerball is only 1 through 26, so it's inclusive. So 26 can be chosen. So just behind the scenes, Python has code to pick a random number in that selection and assigns it to Powerball, right? And then in this next one, I'm making another variable called my ticket. And what I'm doing here is I'm appending, or I'm creating a sample of what the sample method does is it creates a list, and it gives me items in that list that are between or including these numbers. I think it's up to not including this last one, so it's 1 through 69. And then I want that list to be 5 items long, and it guarantees you will not repeat. So if I can also manually write the same kind of logic, but this one does it for me. Basically, it just gives me 5 random numbers in this range, and it guarantees it will not be repeating. And so I'm making the Powerball, I'm making the ticket, and then I'm just appending Powerball to my ticket to get my final full ticket, because it's 6 numbers, 5 numbers from the 1 through 69, and then the last of the Powerball of 1 through 26. And then I would just return a tuple of that list. So that's what's happening here. This is kind of like the magic behind the scenes with getting those random numbers, is this statement right here. Is that what you're asking?
For which statement?
This statement right here is like how I get random numbers.
What line is that on?
Line 4.
Okay.
Yeah, so if I were to just call that function, right? So I can do that. So create numbers, and then I don't need to give it anything. And then I can just print the result. I can just
The
do it here.
numbers is the function of selecting random numbers or creating random numbers.
So I define the function name. This is the name I made up. This is called the function create numbers.
Okay.
Yeah. So this is a number. This is a function I defined. This is how you define it. I defined it right here, and then I defined everything that happened inside the function, and then I defined what it's going to return at the end. So this whole process is building the result that I end up here. And so, the result of that, if I run this loop and then run that cell and this cell, this is what I get back from that function. That's my ticket, right? Or my numbers, right? I can throw some print statements in here as well to see the process, right? So I can say print Powerball, and then I can print ticket, my ticket, and then I can print my ticket again to kind of see how the Powerball was added. And then I can return it. So you'll see a bunch of them print out down here. But if I oh, let me run this again to get it into memory. Now you can see I have the Powerball is 6, and then after my ticket ran, random sample range 1 through 70, this is what I get back from that line of code on line 6. I get back that. And then I'm appending Powerball to my ticket. So I'm taking the 6 and I'm putting it at the end of it. And then I'm casting it into a tuple. And that's what you see with the parentheses here. So you have the square brackets, and then you have the parentheses. So that's the code that actually creates the ticket. And then I don't have to make a separate like drawing code, because drawings are going to end up the same thing. I need 2 different cases of them so I can just compare them. So I just call create numbers several times. For my ticket, I do it once, and that's saved as my ticket in memory. That never changes. And then I make a whole bunch of them here. And so I can make 2,000 drawings right there. They're all different. And then I can compare them all. Does that
So,
make
Aaron,
sense? Yeah.
I want to make sure she's finished.
Yeah. Was that clear for you?
Okay. She's got a thumbs up.
Okay. Got it.
So Aaron, last time you mentioned that when it comes to, defining your functions, that you like to do like have your functions do one thing, right? And I'm just wondering if this is sort of an extreme way of thinking, but the function create numbers, it has what, maybe 4 statements. Is it too extreme to do a function that just says, create Powerball, and then another function, create main numbers, and then another function called create ticket? Is that over?
I think that would be for the purposes of this and like the goal we're trying to meet, I don't think this would because you need one thing, right? You're trying to get a ticket, right?
Yeah.
I would say one function to create a ticket is probably pretty good. You could break it down further. I mean, if we wanted to, you can create Powerball, and then you can create the main numbers, and combine them together. But it would be extra code that really, I mean, it would just break. In my opinion, it would break it down too far. But it doesn't necessarily mean it's wrong.
Okay.
Yeah. And so, I mean, the good case of this being reusable is the fact that we had to generalize it. First, we had create ticket. And then we're like, oh, wait, we can actually create the drawing with the same thing. So maybe create ticket's not the best name, but create numbers. And then we can assign the result of create numbers to my ticket and drawing, and then compare those different numbers together, those different tuples.
Okay.
So yeah. And that kind of got me thinking a bit on this here, like the process we were doing. If everybody remembers from last time, we were like making a big list of drawings. And so if we have like 100 drawings here, right? And I could print out my drawings after this loop runs right here. And like here it is right here, like this giant list of all these different drawings, right? They're all different numbers. But like, why do I need to keep track of that? I don't think I would need to keep track of that stuff. I just need to do comparisons and get results and then put those results somewhere. Not necessarily keep all this all these like this whole big list of numbers. I don't know if I need to keep that. I just need to keep the results of the drawing somewhere.
Should we create a dictionary to store these numbers?
We can store the numbers. Well, we don't need to store the numbers. We just need to store results somewhere. And yes, I think a dictionary is a great data collection type that will allow us to keep track of results. And so that's going to lead us to our next, we want to compare the drawing to a ticket, but then we want to determine the number of matches, right? Matches in ticket versus drawing. And then as a subtask, we need to separately determine determine main ticket number matches, and then also determine the Powerball match. Because if you look at the prize thing, the Powerball has a prize. If you match the Powerball by itself, you win money. The Powerball determines prize categories too when you match like two numbers in the Powerball versus, if you match three numbers, you get something, but if you match three numbers in the Powerball, you get more. And then if you match 5 tickets without the Powerball, that's only $1 million. But if you match 5 numbers plus the Powerball, then you win the jackpot. And so we need to determine the Powerball matches by themselves, which will be pretty easy because we're always going to be comparing the last element of that tuple because the Powerball was always appended at the end whenever it was created. So that's really step 5 is determine number of matches versus drawing. And then not only that, we need to record. So we need to like record results somewhere. And then you suggested a dictionary. So maybe we can work on that now. And so before we do that though, let's go ahead and kind of go back and maybe not append something to drawings, but let's just maybe come back with a like a result of a match. So like I guess we need to build a dictionary of results first that we can then like all the keys being whatever, all possible results are going to be the keys, and then we would just count the results based on every time we compare a drawing. Then we can just edit that key. So if remember in dictionaries, you access the values by the keys, but you can also reassign the values with the keys. So
Aaron, would it be possible for you to open up, I don't know what you call these little blocks or whatever.
a new cell?
Yeah, a new cell way at the bottom. And
Yeah,
I can put the code that I came up with, because that might help us format or I pasted the code into the chat.
okay.
That's what I was hoping that you would put in that last cell, the code that I shared.
Okay. Scroll down. Let me see if I can get it. It's really fickle with scrolling, so give me a second. Ah, so you went straight to prizes. Okay.
Yeah. I figured that maybe there would be a point where you would, you know,
We haven't gotten there yet, but we can put that for step 6, right? So for 6, determine prizes.
because the if you look at the code, I think it's what she was suggesting a dictionary, right?
Mhm.
And it would be curious to see how many of the tickets were $2 tickets, or 0-1, and how many tickets were 1-1. Does the first number is the number of main numbers selected, and the right number is the, if it's 1, you know, they had the Powerball. If it's 0, they did not have the Powerball. And so you see the grand prize on line 12, they had the 5 main numbers, and then Powerball is 1, meaning true. Yeah,
You could also do that, right? So you can do trues and falses even if you want to. Yeah. Okay. And so you get the key based on, okay. Yeah.
based on the get method on prizes.
Yeah. So you want to, and if there is no match, um,
Then the default is no prize.
no prize. Yeah.
So I don't know if lines 3 to 13 kind of, you know, get us started on the dictionary that we're talking about creating to track the number of winning tickets.
Yeah. I mean, we could use, well, we need a separate prize dictionary anyway. So we need this, but we also need another dictionary to track results. And but yes, yeah, we can use this though for prizes. So we'll revisit this because I will use this again for the prizes. We just need to update these a bit because this should be 1 million.
If you look at lines 3 to 13, if we kept the keys, but we took away the prize, and instead we used the prize as a counter for the number of tickets that were 0-1, 1-1, 2-1, and that's what I'm wondering if that's how we track the winnings.
Yeah, and I wouldn't use strings as your values. Again, you're diving ahead, you're pushing ahead beyond where we want to be right now to make sure everyone's following along. So like I said, I'll keep this here and we'll go
Okay.
back to building the counter, and then we can revisit this and I can kind of show you the right method. I wouldn't want to use strings for values here. I'd probably want to keep it numbers because we're going to want to do some arithmetic with those. So yeah, so we'll get there. But let's go back to doing the right now we're at determining number of matches in the ticket versus the drawing, right? So we started doing that here, but we were just checking the drawing versus the matches, and we were like I was trying to fill it in real quick and we didn't quite get there. But yeah, if your matches are greater than 3, then you win a winner chicken dinner. That's not really the best way to go with that, but we'll start building the match dictionary now. So let me go ahead and I'll probably put it right here. And so here we can say I think actually, yeah, right there is good. So matches, and we want to make a dictionary, not a list. We want to make a dictionary. And, I want to use that same, I kind of like that idea. Let's go ahead and keep this. But we're going to change up some stuff. So put that there. And then we can just leave all these 0. Okay. All right, so we have matches. And what we have for a key is, this is what Michael said, this is a tuple representing, number of matches in the main ticket, so the first 5 numbers, and then the Powerball. And so this can be 1 or 0, it can be true or false. We'll leave it there at 1, 0 for now. But now we need to go back to our compare, and we don't want to append something. So when you go back to this function here that we have, and we compare, and we can get rid of this because we're going to just compare one thing at a time. And we can say main nums equals 0, and then Powerball equals false. Okay, and what we're doing is we call the compare, we're comparing our ticket, the one that was created first. So the one that's created here, create my ticket, and then we're going to create our drawing. And then, we're comparing those two, and then we're looping over the ticket up to index 5. And we're saying, hey, if my ticket at the index of I, so we'll start at 0, if it's in the drawing of the slice of my drawing, the first 5 numbers, this is taking a slice of that drawing tuple. If it's in there, then I want to, instead of doing matches append, I want to say main nums plus equals 1. So I want to increment main nums by 1. And it's going to do this for the first 5 numbers. So if I match all 5 numbers, main nums will be 5. If I match 3 of them, that will be 3. And then if that is equal, so if the Powerball matches the Powerball in the drawing, then I want to say Powerball equals true. And then I can just return a tuple of main nums Powerball. And then I can do it this way too to kind of show it being a tuple. You don't have to, you can also just return with the comma. And so now when I run compare, which compare is done right here, matches, I think we'll have to do, let's do, yeah, I think that'll work. And then matches will be a tuple. And then I can run my comparison. So and then here we can get rid of that. We can get rid of this, and I'll explain why in a minute. Create numbers for I in range. Now I want to do that. And then I want to do drawing. So drawing equals create numbers. There we go. Do I still have a create ticket? Oh, I think I haven't reset this. I haven't restarted my. So how we made the create ticket function a while ago, and I deleted it. It's still, because this computer's been running since Monday. It's still a memory because this has been up the entire time. So I still have like create ticket as a function that's still defined in my kernel, but I deleted it from the text. So that's another thing with Jupyter Notebook. Sometimes you want to just go ahead and like clear outputs and restart. When you restart your kernel, you're just clearing all the memory out and kind of getting a fresh start.
Aaron, I have a question about the matches.
Yeah.
Do we see those things are just tracking winning tickets? Do we want to add 3 more tuples, 0, 0, 1, 0, and 2, 0? That way we capture all possibilities. Are we just trying to track winning tickets or just track outcomes?
You just want to You just want to track winning tickets.
Okay.
Because then you can just assume everything else is a losing ticket.
Okay.
Yeah, because even if you match one number or even two numbers, that's not enough to win anything if you don't
Right.
have the Powerball. So, yeah, you don't have to track those. And there's a reason why, because we're going to tie these to the prizes. And then basically when we run the loop, we can also keep track of. We can keep track of money spent. One. Playing Powerball. There we go. Okay. So to recap, this is kind of like my main running file way down here. So all this stuff here is functions I've defined and put up here that can be referenced later once I run this cell. Right now, they're not memory because I restarted the kernel. So there's nothing right now in memory. So if I try to run like this cell right now, it'll error out and say, I have no idea what create numbers is because I haven't run this cell up here. So once I run this cell, you get the green check mark. Now these functions are in memory as something that can be referenced. And then the same goes for matches. Right now it's not in memory because I haven't run the cell. So I run the cell, now it's in memory. And then if I run this now, which I think it'll error out, but let's see. Yeah, it's gonna error out right now, but
Do we need parentheses at the end of line 3?
yeah. And so drawing there, and then we can say we can compare it. So let's not call it matches, let's call it result. Because and let's go ahead and change all these to true. I like that better. So true, true, true. True. I keep forgetting I can do this. I always forget how to do it. Nope, it's definitely option. And then true. And then these three are going to be false. Okay. Cool. So now that should match what we get back from main numbers and Powerball. And so here we're creating our numbers and we're compare, the result is going to be that. And then I can say, matches. Let's go ahead and just print. Let's just print the result first. Let's see what our result looks like. I want to make sure that the result we get from the compare method. So if you look down here, I'm creating a drawing in my range. So I'm going to be iterating over from 0 to 99. So 100 times I'm going to loop this and I'm going to make a drawing. And I'm going to then compare my ticket that I created outside this loop. So that's going to stay static. I'm going to compare it to this new drawing every time this loop iterates. And then I'm going to get a result. And I want to print the result out. So I want to see what happens. The result is the return of this method up here. I want to see what comes back to me 100 times. So if I run that, this is what I get back. So I get back a tuple with 0 and false. So what does this mean to me? It means I matched no numbers and I did not match the Powerball. This next one, the next drawing, I matched 2 numbers, but I did not match the Powerball. That's lots of ones and false, 0 false, lots of those, right? So that's the result I want. And so now I should be able to reference matches and do a get of the keys. And if it matches, then I can increment that key. And I can do it 2 ways. I can use the .get method, or I can just see if, so I can say if result in matches dot keys, then I can then run my increment method there. So if result in matches dot keys matches result plus equals 1.
Question.
Yeah.
Hey, Aaron, just to clarify, on this code, are we having 100 tickets with 100 different drawings? Or do we want 100 tickets with one drawing?
So right now we have one ticket and we're keeping it static and we're comparing it to new drawings every time.
100 drawings?
100 drawings. Correct.
Okay.
Yeah. Now, if you want to, you can just throw my ticket in here and create 100 tickets and 100 drawings to compare these things differently.
Or 100 tickets and one drawing, right?
No, like right now, if I move this down,
And move the drawing up?
right, then you'd have one ticket and you'd have several tickets in one drawing. This is
Which is-
typically how people play. This right here is how most people play the lottery.
Oh, really?
Right.
I thought there was, everybody bought a ticket and then they had one drawing.
So
And so you-
with the lottery in real life, you can buy as many tickets as you want. So you can buy a 20 line ticket that has all these different those are all your numbers, right? Most people do quick pick. So that means every time there's a drawing coming up and they want to buy a ticket, they'll say, give me 20 quick picks. So they're going to get 20 tickets, then they're going to compare it to one drawing.
Right, one drawing.
Right. So what we're doing with this is we're going to keep track of spending over time. So we're not only making a lottery generator, but we're going to simulate playing the lottery over however long we want to, whether it be a year, 2 years, 3 years, 4, to realize, earning potential.
Okay, for one person.
For one person. Yeah.
Okay.
Yeah. So this is how most people play lottery, but for our purposes right now, we're going to keep this up. Dang it, I always use the wrong one. We're going to move it up here for now. And that way we keep the same ticket. So we're going to pretend like we picked our numbers and we love those numbers and we want to keep using those, because some people play lottery like that too. They always use the same numbers. So here we want to just see, okay, so we have matches and we're going to, at the key of result, which will end up being a tuple, so something like this. If it's in there, we know we have a winner, and I want to increment it by 1. So we can see how much we've won these results over 100 drawings, or 1,000 drawings, or 10,000 drawings. Let's just start with 100 for now. And then let's go ahead and print matches. So print matches right there. I run that. And now we get, this is the matches dictionary. And out of 100 drawings, we won $4. Oh, look at that one. So we got a few more winners now.
Don't we have a 5-1? Or is that something else? Oh, the 5-1 is 0.
Yeah.
Okay.
You won't see that one ever.
What about, could we do this, Aaron? Could we just say, run your code the way you have it, but then say, if, I don't know, if result is in winnings, print. If result is in prizes, print winner or something, or
Yeah.
print people.
Yeah, I'll have to change these to trues, but yes.
So it would only print, I guess, if we have a match, a winner.
Right. So you can do it this way, and then And so you're saying right here, say if result. If result. Well, actually, I can just do it right here because I know it's in there then. I can just say print prizes result. Let me run this. I will need to remove this because it's in a function. Right there. Now let me run this. And then run that. Boom, boom, boom. Which these prices aren't correct, but we'll get there. They're not the right ones for the Powerball.
I went off some website.
Yeah. No, the Powerball prizes.
They're higher, right?
Some are. Yeah, some are higher. Powerball prizes, games, Powerball. Where's the prizes? Prizes and odds. Here it is. Okay. So you match a Powerball, you get $4. $4 with one number in Powerball, sevens, and then 150,000, 1 million grand prize. So let's do this. Let's make this smaller. We'll adjust the. Oh boy. Okay, there we go. Then we can move this over. That's all we need right there. And so it's $4 and $4. 7 and 7. I think those are
100, 100.
yeah, I just want to make sure this ad is in the way. Good night. It's covering my content. Goodness. Okay. Let me just make it bigger. There we go. Good night. Okay. So yeah. 3 in Powerball and 4. So 3 Powerball is 100, 100. So you did put these in order. Okay. 100, 100. 4 is 100. 4 plus Powerball is 50,000. 1 million, and then the grand prize. We'll put money signs. There we go. Just in case we hit it. We want to see that.
Oh, you said you didn't want strings, right?
No, again, we're just referencing this right now to kind of see a quick result, right? So right now we're just checking to see if it's in there. We were printing out. So this time we won one. Let me run this again. It shouldn't be $5. There you go. We won $4 4 times out of 100 drawings. We won $32. No, $16. $8.
I feel like we lost $84.
Oh yeah, you're not
Well,
winning money.
are they $1 each or $2 each?
They're $2 each.
Oh, we lost a whole lot of money.
Oh yeah.
$184.
I don't even have to do any more statistical analysis. Tell you, like, show you that playing lottery is a terrible bet, right? You can see this right here. So yes. So to recap, because I know we've done already quite a bit right now. Do we have any questions on what we've done so far, and kind of is everyone following along? Do they want anything explained again to kind of see what's happening? Again, I've broken my code up into some functions up here, and I kind of put them up here neatly and I keep them there, right? I don't really care to go back to them unless I need to change something in them. And then we have these 2 dictionaries, one called matches, one called prizes. And we'll change these up because we want to keep track of like a running total of money at the end. And then this is like my cell that kind of runs everything. So this is kind of almost like a runner file that defines a ticket and it, it doesn't define the ticket itself. It calls the method or calls the function create numbers, and that function does it for me. I don't care what it does. All I want to do is call that and get a ticket. So all I care about is calling this function and getting back a tuple that has 6 numbers in it. And then I'm making a for loop in here, and I'm using the range method because I just want to run it a certain amount of times. In this case, I want to run a loop 100 times. And every time this loop iterates, I'm making a drawing. And I'm calling that same function that I use to make a ticket. I also want to create the drawing because they're created the exact same way. You want them to be the same because you want to be able to compare them. And that's what I do next. I make a new variable called result. And that's equal to the results of whatever this compare method's doing. And the compare method that we wrote up here takes 2 parameters, the ticket that I had already here and the new drawing I just created. And if we take a look at that, it does some stuff inside. I don't really care what it does. I just want to return a tuple that tells me how many matches I have of the main numbers and then if the Powerball matches. And then I'm going to go look at matches. I'm going to look at this dictionary, right? And I want to know, hey, my result that I just got in this iteration, is it in the keys of matches? So does the result match this key? If it's in there, if it's in that list-like object of keys, then do this stuff. If not, do nothing. And then if it is in there, then I want to go ahead and reference my matches dictionary and increment the value by 1. Whichever one I won, I want to make sure I increment that. And then next, I want to print the result of I want to print the prizes at the key of result that I had. Just give me a visual representation of how much money I won in that drawing. I said that's what's happening here right now. And it's just giving me back, this isn't refined or anything. This is, it's still like a work in progress, but we're getting there. We're getting some data types to use later on. Now, if you notice, I won 1 time here, right? On this iteration, I ran this, it went through 100 times, and I won exactly 1 time because I have 1 $4 thing here. But it's showing that I've actually got, like, I matched 3 numbers. And 3 numbers with false is $5. Or not $5, it's $7. Oh, I won a lot that time. But it's saying I matched the Powerball 19 times. But how come I don't see 19 4s here? Anybody have any suggestions?
It looks like you have a $20 winner, that 3 false 1.
The 3 falses, well, I remember I redefined them up here. So this is what
Yeah.
prizes is. I haven't run this, so
Okay.
yeah. We can probably hide this or some of those commented out so we can't see it. But yeah, if you notice, like now it's 22. But I've only won 5 times. Let's bump this up. Let's go 10,000 drawings. That's a lot.
What if we do, since the Powerball, I think it's like 292 million, out of 292 million possibilities of winning or chances of you winning the Powerball. For this example, we've limited that.
Correct.
We're not. Okay. Is there a way that we can see, like, how would that look?
How long it would take to like win the Powerball?
Yes.
Sure. We're actually pretty close to getting there anyway, right? But let's think about this realistically, right? how much time would it take to go through 10,000 drawings? In like real time? How many drawings are held per week?
Oh, okay, yeah.
2, right? So, I mean, so a year, we only have 104 drawings a year.
100 years, I think.
So, yeah, I mean, you don't really have a way. I mean, you just have to get extremely, crazy lucky to win lottery. Like, just you're not gonna win. So, but yeah, we can run a loop until we see a winner. And we could, in that case, I'd want to use a while loop. And then when I do that, I want to maybe like keep track of a count. And then whenever we hit the main Powerball, like then at what drawing number did that happen? You want to keep track of that and then print out something. We could do that. And I could run the script. And I would say after about maybe 1 or 2 minutes, it would probably finally hit something. I think. But yeah, we as a thought exercise, let's try it out. So let's do that instead. So we can keep a lot of this logic, but let's just make a new loop. And we can say while so hit. So let's do hit equals false. And we can write a new variable called hit equals false. Do a double equals here. And then we can do the same thing. So we can start here. See, copy that down. Get rid of that. And we'd only have to do if result equals 5 true.
Could we do or 5 false or 4 true, just any of the big prizes? Because maybe it's more realistic.
Well, yeah, but here's what I'm gonna do too. It's gonna be cool. Watch this. So count equals 0. Print you won at drawing number count. Send the F string here. And then we can comment all that out for now. All right, so we have my ticket, we create numbers. I'm making a new variable called hit equals false. And I'm also making a count variable because I want to increment count. And then, which I haven't done yet down here, while hit equals false, it's going to just run boom, boom. I'm creating a drawing. I'm doing my comparison. And then the only thing I care about is this one right here, which is the grand prize. And then I want to say break. And outside of that, I want to count. I want to increment my counting here. Count plus equals 1. Yep, because if I hit on the first one, then it'll say you won at drawing number 1. Okay. Let's see how long it takes.
We could be here a while.
We could be. Now my computer counts pretty quickly. So we'll see. I wonder what number it's up to already. Maybe 10 million?
Wow.
I could keep track of that actually. I'm gonna hit eventually. I have to hit.
What's the
Any
over and under?
hazard?
So I said a minute to 2 minutes, right? I said
Okay,
that's the window.
This would be a loop.
This is a loop. It's looping. Yeah.
Can a hacker interrupt the loop
What's that?
process? Can a hacker interrupt the loop process?
Yeah, you get interrupted by hitting the stop cell execution right there.
But what if someone was trying to like actually control like the Powerball? Or like the, I don't know, something extreme. Um like in a real life situation where someone was trying to I guess interrupt the system of how we generate within numbers.
Well, the generation of winning numbers is in the it's in like the hopper, right? So it's physical because you need to have a real random number generator. And so Python, any computer is not going to create real random numbers. They're all pseudo random. So they use the actual physical process to create the numbers. Looks like we still went beyond 2 minutes. Hey, you know what? I realized I'm never gonna stop this loop. This is a continual running loop. You know why?
Well, I was gonna ask you if you're gonna take hit and reassign it to true,
Yeah, we
but
probably
but
already
I
hit.
thought, but I thought the break would do that.
Yeah, it
That was-
should actually. Yeah, the break should do that. So we never hit. But let's do this. Let's do if count if let's say count modulo 1 million equals 0 print count. Now, only whenever you have a million, like a number evenly divisible by million, will you see the count and where you're at.
see, I'm wondering if for line 18, we should be so greedy, and we should say if result equals the tuple 5 true, or 5-0, or whatever, and try to win 50,000 before we win the grand prize, because just to see if we can make that happen.
Yeah, you'll hit it eventually. Yeah, we can do that. So if result equals that, or result equals 5 false, right?
Yeah. Or I think it was 4-1 or 4 true is
That's
50,000.
I want to, I'm concerned with becoming a millionaire. Just keeps going, doesn't it?
Mhm.
You made it too realistic.
It's good that you're not tracking the money you've lost.
Hey, look at that.
There we go. But which one did you win? Can we see? Can we tell which of the two?
Well, I have to print it. So no, it's done. The loop's over and we don't know what we won. We won something.
Mhm.
And it only would have taken like we're looking at the scale of like era scale. So
Well, we don't know how many tickets you're buying per week, right?
right.
If you're buying 1,000 tickets per week, then and you got 2 drawings per week, so yeah.
Yeah. So you're spending $2,000 a week. So yeah, so that's a good little thought exercise, kind of see how it works. And so cool. Let's take we didn't take a break. Kind of you can just take a break whenever, but I was gonna go ahead and take about a 10-minute break. And then we'll be back and we'll just continue this this exercise.
I'll stick to the racetrack.
There we go. I'm a poker player myself, and so I'd rather play against other people than the house. I feel like I stand a better chance against other people. Let me pause the recording.